Hello students, welcome back. In section 1 we went through implicit differentiation as technique. Now let's do the application problems associated to some geometry. We are going to focus upon implicit curves this time. Let's begin with some examples. Okay, an ellipse. We went through this before. Descartes volume. Okay, we went through that too. Let's consider some tangency problems, and basically this is what you want. Point usually will be given, so x0, y0 is there. What you need to find out is the slope. Remember, slope is a derivative, so we need to do the derivative computation, but this is implicit curve, so we have to take the derivative for implicit relation. You have to do the implicit differentiation technique. And then one more thing to worry about. Let's suppose that the problem gave you this point, and you take the derivative implicitly, plug in the numbers, and find out y prime evaluated here. That's going to be the slope. And then you're going to get this tangent line. That's going to be y equals to the slope m. Yeah, that's the key part. X minus x naught plus y naught. Yeah, you can do that. But there's some cases you end up with this point, this kind of point. And the tangent line is a vertical line. In that case, you'll see m is undefined. And in that case, x equals to something. This kind of situation did not appear for tangency problems for graphs. For implicit curves, you have to consider this. So if you have a graph, or if you plot your graph using the graphing calculator app or whatever, and if you have an anticipation of vertical line, great. But if you do not have an anticipation and then somehow you stumble upon this, sometimes students may end up panicking because you may end up with something like without m expression, you're going to get something like 4 equals to 0, those kind of thing. M expression just disappear, cancel out, and you get something ridiculous. And that's an indication that m does not exist. The derivative does not exist. If you have an equation of m and work out, then you're going to get appropriate slope. And that's going to be the majority of the case, 95% of the problem. But the other 5% of the problem may be singular case. So please remember that singular cases do exist. Okay, let's go to an example problem. Okay, all right. X squared plus 3y squared plus 2xy plus x equals to 1 at x comma y is negative 2 comma 1. We are doing this for the first time. So this time, I'll show you the picture first. So you're looking for something like this. We're going to end up with an ellipse. And then this point here, negative 2 comma 1. And then you expect a positive slope. All right. We have point negative 2 comma 1. So you know you have this kind of anticipation. Plus minus 1, so plus 2 plus 1. Is this actually negative of negative 2, but nobody writes like this. X minus x naught. So let's write like this. And then of course m is the question. And then if m does not exist, then you have to go with the vertical line. Okay, how to solve it? Well, slope is a derivative, so we have to solve this through implicit differentiation. So let's go ahead and do that. What's the derivative of x squared? Is that clear to everybody? What's the derivative of 3y squared? 6y, but don't forget y prime. Do not forget y prime. Whenever you take the derivative formula by x, no problem. Whenever you take the derivative by y, y prime pops up. Next, we have a product 2x times y. The derivative of first function is 2 times y. And then the first function 2x times the derivative of second function, that's y prime. I don't need that many dots here. And then here, highlighted in red. Okay, now derivative of x is 1. Right hand side, one of my common mistakes will be this. By the time you got all this to the left hand side, you get exhausted and then just keep it there. Nope, the derivative constant is 0. Alright, one way to do this is to solve for y prime just like you did before, and then plugging in x value, y value, but that's a bit too much of work. It's going to be easier to plug in the numbers now. Alright? Previously, if you have to solve for y prime symbolically, if the problem asks you, then go ahead and do that. That's what you have to do in section 1. Here, if you're looking for a tangent line, don't bother. Just plug in the numbers now. So let's copy and paste this entire thing. And then x is negative 2, alright, plug in negative 2. Y is 1, alright, plug in y is 1. Y is 1. And x is negative 2. And we have a numerical equation now. Shall we simplify a little bit further? Okay, alright. Let's copy and paste this thing and let's simplify a little bit further. That's negative 4. And then this is 6y prime. And this is 2. And 2 times, that's negative 4. And then we have plus 1. Never mind, let's stop here. Okay, alright. So 6 minus 4, so we have 2y prime. And as for number part, negative 4 plus 2 plus 1, overall I have minus 1. Okay. That's easy. 2y prime equals to 1. Y prime is 1 over 2. And this is my slope. Here, y prime is the derivative. After plugging the numbers, we are looking for y prime, yes. But this time, it's a slope. Y prime evaluated at x equal to negative 2 and y equals to 1. If you feel totally okay about this, and then write answer like this, okay, let's go ahead to answer. Therefore, okay, if you go ahead like this, totally fine. Now, there may be some students who will get a little bit confused with this y prime or dy dx expression. Or sometimes you may want to protect yourself from possible mistakes. In that case, do it this way. When you plug in the numbers, alright, after taking the derivative, when you plug in numbers, x equals to negative 2, y equals to 1, and as for y prime, plug in m. X is negative 2, y is 1, and y prime is m. And this way, y prime is a function, m is a slope number. And you can reduce some confusion there. It's not really necessary, but it's a good way to reduce some possible stupid mistake. The moment you have m, no more character, no other character. What did I do here? Implicit differentiation, all right. And then plug in x is -1/2, x is -2, y is 1, and y prime is m. Solve the equation, and then the slope point equation. The same thing I did earlier. Okay, there are many more problems here. Stop the playback and try. Want to go ahead with the second problem now? I assume you stopped the playback and tried and got the answer, or at least you tried and got stuck. Okay, this time let's do that without the visualization. Let's suppose that you have to do this without calculator. Okay, all right, let's take the derivative implicitly. 2x, all right, and the product rule. Something's not right. I made a typo here. This is negative. Okay, all right. Okay, all right. Oh. What do I have here? Okay, all right. Sorry about that. If you stopped the playback and did a lot of work already, there was a typo. That should have been negative. I forgot about that. And then if you do it right, okay, negative sign there. And then plug in x value, y value there. X is -1, y is 1, y prime is m. And then break up parentheses and so on, solve this equation. M is -3/2. Okay, there goes the solution. And there goes the visualization. -3/2 is the slope, and the point the problem already gave you, -1, 1. I'll correct the typo. It should have been negative here. Let's try the third problem here. Have you tried? Stop the playback and went through? Okay, in this case, dealing with this exponential may be a bit of a challenge. How did you do that? 2x, so far so good. And here is a product of two functions. Negative exponential times y squared. So okay, take the derivative of the first function. It's an exponential function and inside never changes. And the derivative of inside is just 1. So no change there, y squared. And then times derivative of y squared, 2y, y prime. And then the derivative of 2y prime, and the right hand side is 0. And you're looking for y prime value. So is that what you got? Here's the solution. The main part is this product rule. Oh, I used the minus and then used product rule and then broke up the parentheses. I used -e to -xy right away. It's the same thing. Plug in the numbers. And then solve for m. M is -1. So we have the solution like that. Visualization right here. Let's come back and discuss the rest of the problems in a separate video.